Figure 6 shows a sketch of the curve C with parametric equations. X equals 2 tan t plus 1 and y equals 2 sec squared t plus 3 between negative pi over 4, the t values between negative pi over 4 and pi over 3. We've got a line L, a normal to C at the point P, where t is pi over 4, and using parametric differentiation, show that an equation for L is y equals negative half x plus 17 over 2. So parametric differentiation, we're going to find dy dx, and we're going to do that by doing dy dt divided by dx dt. So we can find dy dt and dx dt. So x is 2 tan t plus 1. So dx dt, when we differentiate tan, we get sec squared. So it's just going to be 2 sec squared t. Y is equal to 2 sec squared t plus 3. So think of it as 2 sec t squared plus 3. So we're going to times by the power, take 1 off the power, so that's just 4 sec t, times by the bracket differentiated. Sec differentiated is sec tan. So it's 4 sec t times sec t tan t, or simplified 4 sec squared t tan t. So dy dx is dy dt, which was 4, so dy dt, 4 sec squared t tan t divided by dx dt, 2 sec squared t. So we can cancel the sec squared t's, divide by 2. So we've just got 2 tan t. When t is pi over 4, when t is equal to pi over 4, we're going to have 2 tan pi over 4. Make sure the calculator is in radians. So 2 tan pi over 4 is 2. So that's the gradient. That'd be the gradient of the tangent. The gradient of the tangent would be 2. So the perpendicular gradient is minus a half. So the perpendicular negative reciprocal minus a half. So we wanted that. We also need to find the x and y coordinates. So when t is pi over 4, what is x, what is y? So x equals 2 tan pi over 4 plus 1. 2 tan pi over 4 plus 1. That is 3. And y is 2 sec squared pi over 4 plus 3. So sec is 1 over cos. Let's have 2 over cos pi over 4 squared plus 3. So 2 over cos pi over 4 squared plus 3, and that is 7. So we've got 3, 7. We've got the gradient as minus a half. So we can just use y minus y1 equals m times x minus x1. So y minus 7 equals minus a half x minus 3. Expand the brackets, so minus a half x plus 3 over 2. That's y minus 7. And add 7 to both sides. So y is minus a half x. 14 over 2 plus 3 over 2 is 17 over 2. And that is what we wanted for part A. Part B, show that all points on C satisfy the equation y equals half times x minus 1 squared plus 5. So we want to change from parametric equations into Cartesian equations. And when we have these, well, I've got tan and sec this time, we can use our identity. So cos squared x plus sine squared x is equal to 1. There's one that connects tan and sec. So if I divided each term by cos squared x, I'll get 1 plus tan squared x equals sec squared x. So we can use this identity. If we substitute in tan squared x, so I can make this one equal to tan squared x, so x equals 2 tan t plus 1. Take 1 away. Divide by 2. So that's tan t by itself. Square both sides. X minus 1 over 2 squared equals tan squared t. So I can substitute that in for tan squared t. How about sec squared t? That's actually easier. So we know y equals 2 sec squared t plus 3. Take away 3 from both sides and divide by 2. So there we have sec squared t and tan squared t. If we substitute in for these, we get rid of the tan and the sec, and we just have x's and y's left. So let's substitute in. So 1 plus x minus 1 over 2 squared equals y minus 3 over 2. Now it's just a case of rearranging this. We'll make y the subject, and that should be it. So I'm going to change this squared, so the top is squared and the bottom is squared, because I want to keep x minus 1 squared. I'm going to keep x minus 1 squared, so square the top, square the bottom. Now I'm going to get rid of the fractions. So if I multiply everything by 2, times everything by 2, times each term by 2, that would be 2 plus x minus 1 squared over 2. So if I double it, I can cancel off 2, equals y minus 3. And then I'm just going to add 5 to both sides. I've made y the subject. And just instead of this 2 as a fraction, I'm going to change it to times by a half. So y is a half times x minus 1 squared plus 5. And part C, so the straight line of equation, y equals minus a half x plus k. So there's a line parallel to this line here. But we don't know what its y-intercept is, so it can be anything up and down this line. Intersects C at 2 distinct points. Find the range of possible values for k. So where would it have to go to intersect at two distinct points? So it can be here, where it's just touching this point here, or it would have to be there. So not where it's got one solution, not where it's a tangent, anything further up. So we just need to find what k would have to be for these two lines. So let's use the equation. So if it's a tangent, so for this one here, this purple line, if we solve them simultaneously, and there'll be one solution. So we can use a discriminant, and that will find where it is a tangent. So they're both y equals at the moment. Let's make them equal to each other. So minus a half x plus k equals half times x minus 1 squared plus 5. So that's where our straight line and curve intersect. And we want to make it equal to 0. So let's just do some expanding and simplifying. X minus 1 squared is x squared minus x plus 1. And I think let's double everything. Let's get rid of these fractions. So double every term. Double the 5 makes 10. Make it equal to 0. So we've got x squared. Our x terms, we've got minus 2x plus another x. That's minus 2x plus x, so minus x. And then we've got 1 and 10, so 11. Take away 2k. So that's our c term. So we know if it's a tangent, it's got one solution for the tangent. So b squared minus 4ac will be equal to 0. And that will be negative 1 squared minus 4 times 1 times 11 minus 2k equals 0. So 1 minus 44 plus 8k equals 0. So 1 minus 44, negative 43. So 8k equals 43. K is 43 over 8. So that's for it to be a tangent. So we know it's going to have to be bigger than 43 over 8. So k has to be bigger than 43 over 8. But also, we're going to need to find this point. So if we go back to our parametrics that we started with, t can only be between negative pi over 4 and pi over 3. This point here will be when it's negative pi over 4. So we can find the coordinates by substituting negative pi over 4 in for x and y. So x is 2 tan negative pi over 4 plus 1. 2 tan negative pi over 4 plus 1. That's negative 1. The x coordinate is negative 1. That looks about right. And y is 2, again, sec squared. So that's over cos squared. And it is negative pi over 4. It's squared plus 3. So 2 over cos negative pi over 4 squared plus 3 is 7. So we've got negative 1, 7 as our coordinate of that point. We know y equals minus a half x plus k. So what does k have to be? So 7 equals minus a half times minus 1 plus k. 7 equals a half plus k. 7 take away a half is 6.5 or 13 over 2. And it'll be 13 over 2 there, so it can be less than or equal. K is less than or equal to 13 over 2. So let's put our two parts together. So it's bigger than 43 over 8. K is bigger than 43 over 8 and less than or equal to 13 over 2. So that is our answer.